Oh, that was funny. I didn't remember that one.
Okay, so today we're going to talk about the number e. And draw a graph. And the function y is equal to e to the x looks something like that. And it crosses the y-axis at the point 0, 1. And e was formulated really because this graph, where it crosses the y-axis, the slope of the line tangent at 0, 1, the slope is equal to 1. Now, its inverse looks like this. It's y is equal to the natural log of x. And we'll do a section on, section 5.3 is about inverses, and that's a bunch of pre-cal stuff too. So this test actually has a lot of stuff in it that is not even calculus coming up. It's just, I'll remind you how to do the pre-cal. But this inverse crosses the x-axis at the point 1, 0. So natural log of x and e to the x are related. Now, a few facts about e. E is approximately equal to 2.71821, and it just goes on forever. E to the x has a slope of 1 at the point 0, 1, which I've already mentioned. E is very important in modeling things that occur in the natural world. And the main thing, the kind of problems we'll look at a lot that involve E, but one of the main ones is population growth. And we did a lot of problems in pre-cal like that. E to the x and natural log of x are inverses. And just to remind you what natural log is. Natural log is just log base e. Any of that ring a bell? Okay, so to remind you about logs, a log is an exponent. So that's really the key thing to remember. So if you see log base b of a is equal to c, and just what that means in sentence format is that c is the exponent. That you must raise b, the base, to get a. So the answer, in this case the answer is c, it's always going to be an exponent. So if we had log to the base b of a, and we wanted to rewrite that, I'm sorry, I forgot the c part, is equal to c, if we were to rewrite that as an exponential function, that would be b to the c power is equal to a. So I kind of look at it as a pattern. Base to the answer is equal to a. So just to remind you of the stuff that we did about this time last year in pre-cal, if we were to evaluate log base 2 of 8, we would just rewrite that as an exponential. That would be 2 to some power x is equal to 8. Right, so x would be 3. If we were to take the log base 2 of 1/4, that would be 2 to the x power is equal to 1/4. Okay, so that's going to be, x would be negative 2. So just in case you've forgotten, that's the same thing. 2 to the negative 2 would be 1 over 2 squared, which is 1/4. So I know we haven't done those in a while. Log base 2 of 2, we could rewrite that as 2 to the x is equal to 2. So x would just be 1. And log base 2 of 1, we could write that as 2 to the x is equal to 1. And what exponent always gives you 1? 0. Really? Okay, for the video, I'm going to go ahead and rewrite these properties. I'm going to leave these up for a while, but you'll want to put them in your notes. I'll just go over them all real quick. The properties of logs are really useful when doing calculus, because they can make a calculus problem, if you're taking a derivative or integrating, can make it a whole lot easier to work with. So for example, if I have log base b of a times c, I can rewrite that as log base b of a plus log base b of c. Okay, so if we have a product, multiplication, we can split them apart. Do you remember doing that last year? Okay, split them apart. And that can make the calculus a whole lot easier. If we have log base b of a over c, okay, that's the same thing as log base b of a minus log base b of c. So if it's division, then we use subtraction to split it apart. And then if we have log base b of a to the c power, does anybody remember? Well, it's up on here, so. But what you do is you can bring the exponent out front. Okay, so that's going to be c times log base b of a. Now, if you just have log of a and no base is given, what is it? Does anyone remember what base it is if no base is given?
10?
10, that's right. So that's log base 10 of A. And log base B of A is, log base E is the special one we've been talking about. That's the natural log, which you have a button on your calculator for natural log, and you have a button for log base 10, but you can also do a log of any base, which we'll get to. So we call that the natural log. All right, and I've written on the board here, there's a few other things, and I'll go ahead and write them here for the purposes of the video in case you can't see it over there. Log, the natural log of e to the x. So you would bring this x out front, it'd be x times natural log of e, but natural log of e is 1, so that's just x. That's a really handy thing to remember. It can save you a lot of time if you can remember that. The natural log of e is 1, because what you're saying is e raised to what power gives you e? That's what that's telling you, so that's going to be 1. E to the natural log of x, the e and the natural log, they cancel each other out, and all you're left with is just x. So that is really handy to remember. And then the last handy dandy thing to remember is the natural log of 1 is equal to 0. Now we'll work a few example problems, and on page 318, and that will actually be the end, the official end of the first lecture. The first one is example 16 on page 318. And the instructions say, write the expression as a sum difference or a multiple of logarithms. So we have the natural log of 1/5. Okay, so we can split that apart and use subtraction. That's going to be the natural log of 1 minus the natural log of 5. Well, what is the natural log of 1?
That is 0.
That's 0. So that's the same thing as 0 minus the natural log of 5, which would be the negative natural log of 5. All right, number 18, we have the natural log of x times y times z. And this, since it's all multiplication, we can just turn it into 3 separate natural logs with addition. So that's the natural log of x plus the natural log of y plus the natural log of z. We can't really do anything more than that. All right, number 20, we have the natural log of the square root of a minus 1. Now what we're going to want to do there is take the square root of a minus 1 and rewrite it to the 1/2 power. Okay, so this would be the natural log of a minus 1 to the 1/2 power. And then what can I do with that 1/2?
Take it out front.
Okay, I can bring that out front. We'd have 1/2 times the natural log of a minus 1. Now I can't do anything more with that a minus 1. All right, number 22, we have the natural log of 3e squared. Well, this is multiplication, so I can split them up into 2. So I'd have the natural log of 3 plus the natural log of e squared. But I can also do something else with the natural log of e squared. I can bring that 2 out front. So this would be the natural log of 3 plus 2 times the natural log of e. What is the natural log of e?
1.
It's 1. This is just 1, so that's going to be the natural log of 3 plus 2. And that's as simple as I can get it. All right, number 24, we have the natural log of 1 minus the natural log of e. Well, the natural log of 1 is 0. The natural log of e is 1. So that's 0 minus 1, which is negative 1. Now we're going through all of this to remind you how to do it so that when we get to the calculus, which would be the lecture I'm about to do in a minute, you can rewrite it. And when you rewrite it, it can make the calculus like super easy. Because if we were to take the derivative of that, well, the derivative of negative 1 is just 0. Okay, so after I go through all that simplification process, then that's really helpful. All right, number 26. We have 3 natural log of x plus 2 natural log of y minus 4 natural log of z. Now the first thing you always want to take care of is, let's go ahead and make these coefficients into exponents. All right, so I'd have natural log of x cubed plus the natural log of y squared minus the natural